This is lesson 1.3, inequalities, and this is video 1. We are working with axioms of inequalities, distinguishing between positive and negative numbers. Axiom 1. The axiom of an inequality, among all numbers of the system, there is a set called the positive numbers that satisfies two conditions. The first condition is for any number a, exactly one of the following three alternatives holds. A is positive, a equals 0, or negative a is positive. Since a and negative a are opposites, only one can be positive, and only one of them can be negative. Only one can be greater than 0, and only one can be less than 0. A and negative a are opposite numbers. If a is less than 0, then negative a is greater than 0. If a is greater than 0, then negative a is less than 0. So they're opposites. So only one can be greater than 0, one can be less than 0. The second condition is any finite sum or product of positive numbers is positive. So we're talking about finite sum. So we're talking about a plus and a plus, 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 or product of positive numbers is positive. So any product of positive or any sum of positive numbers is positive. Okay, definition. A negative number. So a number a is negative when negative a is positive, again because they're opposites. If a and b are any numbers, then a is greater than b whenever a minus b is positive. So if a minus b is positive, then a has to be greater than b. Okay, the open interval. Here we have open parentheses on a, open parentheses on b, and we have a set of numbers in between. If a and b are numbers, then the open interval from a to the open interval to b is the collection of numbers that are both larger than a and smaller than b, or all numbers between a and b, such that a is less than x, x is less than b. So again, you get all numbers between a and b, but not including a and b, because you don't have that less than or equal to on either one of those. Closed interval, you have a closed bracket on a and a closed bracket on b, and all numbers in between are in the solution or part of the set. All points between a and b, including a and b, where x is greater than or equal to a and x is less than or equal to b. So now we're looking at half open on the left. So if we're looking at this on a number line, where this is A and B, it's open on the left, closed on the right. So x is greater than A, but not greater than or equal to A. So x is greater than A, but less than or equal to B. So it's going to be open parentheses at A and closed bracket on B, because of the less than or equal to on B. So you get open parentheses on A, comma, B, closed bracket for the interval in interval notation. Half open to the right. So here B is open and A is closed. Then x is going to be greater than or equal to A because it includes A, but less than B. B is going to be open because it does not include B. A is closed because it does include A for the less than or equal to. unbound cases, set of all numbers greater than a. Now normally we could have just said x is greater than a, or we could have written this as x is greater than a like that, but it wouldn't fit as well with the inequality sign, because we'd have to put the inequality sign the other way to show infinity is greater than a. So this is a better way to write it as far as x is less than infinity. X is greater than a but less than infinity, because infinity goes on as infinite numbers, and x is going to be somewhere in between. So we say a is open interval at a to infinity. All numbers less than b would be x is less than b but greater than negative infinity. So we would write this as an open parentheses negative infinity to b. Alright, so that's all there is for this part, and then the solution to an inequality comes next, in the next video.